In this section, we're going to focus our study to just looking at parabolas. Parabolas are probably one of the most common types of graphs that you would see in other areas like science and business. So before we get started, I want to do two quick warm-up questions. So for starters, on the first one, let's sketch the graph of y equals x minus 3 squared plus 4. Now, since we just finished the section on shifting graphs, we know that this graph has x squared as the parent function. So y equals x squared is our parent function. And we also know that the negative 3 inside moves the graph to the right 3 spaces. And the plus 4 on the outside moves the graph up 4 spaces. So because we've already practiced this in the previous section, I'm just going to go right to what that looks like. We're going to take our parabola from y equals x squared, move that parabola right 3 units, up 4 units, and as best I can draw our parabola. Cool. So basically what that did is that took the vertex, which was previously at 0, 0, and it moved it, this new vertex, that ordered pair right there, at the lowest point of the graph is at x equals 3 and y equals 4. And we call that point, that lowest point of the parabola, the vertex. So on the regular parabola y equals x squared, the vertex would be at the origin. Okay, let's do another graph. Let's sketch, f of x equals negative 2 times the quantity x plus 1 squared minus 3. Okay, so just like in the very last problem, we have horizontal shifts and vertical shifts. So this plus 1 moves our graph to the left 1. The minus 3 moves the graph down 3. And the negative on the outside, if you remember, this is a reflection. Let's see, if it's outside of the function, it's changing the y values, so it's a reflection about the x-axis. And then the 2 in the front is a stretch. So with this 2 in the front with the stretching, we'll plot a point. But we can do all the other stuff without plotting points so much. So we're going to take our regular y equals x squared. And remember, we go in alphabetical order. So horizontal shifts first. So we're going to move left 1. Then we do the reflection. So at first it looks like this. Then we reflect it around the x-axis. So then it would look like this. And then we shift it down 3. 1, 2, 3. So we have that graph finally. Now the one thing that I haven't done yet, I'm going to make this actually smaller. I haven't graphed with the stretch yet, with the negative 2. So I'm just sort of doing these mini parabolas so my graph doesn't get too busy with all of the parabolas there that we're moving to the left 1 and then reflecting about the x-axis and then shifting it down 3. So now finally in red, I'll graph, let's see, remember with the shift or with the stretch of negative 2, I'm going to plot a point. And if you're doing this using my math lab, usually you have to plot 2 points, the vertex first and then one other point. Well, I don't know about you, but I'm always for making things as easy as possible. So when I plot the vertex first and then my one more point, I'm going to pick something easy like the Y-intercept. which remember is at x equals 0. So I'm going to plug in 0 for our x value. So that would give us negative 2 times 0 plus 1 squared minus 3. Using PEMDAS, order of operations, 0 plus 1 is 1, and 1 squared is 1. So we have negative 2 times 1 minus 3. Negative 2 minus 3 is negative 5. So our one more point is the ordered pair 0, negative 5. So here we've graphed 1, 2, 3. So we need to go down to negative 5. So our graph specifically, I am the worst at artwork. There we go. Looks like that. And the vertex is up here. It looks like at the ordered pair, x is negative 1 and y is negative 3. And that's this point right here. Okay, actually, we've sort of stumbled upon something really cool. Look at this form up here. If we're doing these horizontal and vertical shifts, notice, and the reflections and the stretches, notice this. The reflection and the stretch had no change on the vertex, right? When we graphed our green here, we hadn't paid attention to the stretch yet, and it didn't change where our vertex was. And the vertex is at x equals negative 1 and y equals negative 3, which, if I get my highlighter out, are visible in the equation, assuming that we do one interesting thing, change the sign of the number next to x. Why? Well, because it was a shift to the left. Remember, those horizontal shifts are always the opposite of what they appear to be. So x equals negative 1 and y equals negative 3 is our vertex. Let's see if it worked over here too. I'll keep the green highlighter. So our vertex was 3, 4. And look at the equation. If I change the sign of the number next to x, because it's a horizontal shift, I have 3 and 4. So maybe we could do a pretty quick sketch of a parabola with that information. So what we have figured out is this. We have a standard, or something that I call a vertex form for a parabola. And that looks like this. Y equals A times the quantity x minus h squared plus k. And the reason we call this the vertex, I call this the vertex form or the standard form, is because we can see, if it's written in this form with all the shifting that's been going on, we can see that the vertex would be at, change the sign of the number next to x, so h, and keep the sign of the number on the outside, k. This is what we're going to use for this chapter. So let's use what we just figured out to sketch the following graph. Now remember, our standard form is y equals a times x minus h squared plus k. So I can see that the a is 3, positive 3, and what's really important is always the vertex. So for our vertex, we have h is 5. Ooh, k isn't written in, must be a 0, and k is 0. So 3, 4, 5, I can't count. 1, 2, 3, 4, 5. 0 is our vertex. And then, like I suggested in the previous one, plot one more point. Now I want to show you something if you're sketching these by hand. If you're sketching these using a program like My Math Lab or your graphing calculator, you'll get a really nice picture. If you're sketching them by hand, sometimes these numbers go off the chart. So our one more point, because we know our vertex, oops, I don't want to put our one more point there. Not enough room. So our one more point, which I suggest is the easiest one, the y-intercept, so x equals 0, would be, I'll call it f of 0, 3 times 0 minus 5 squared is 3 times negative 5 squared. Ooh, negative 5 squared is 25. So we have 3 times 25, which is 75. Holy cow. So we have x equals 0, which is here, and y equals 75, and here I'm going to fudge a little bit. 75. Is that a great picture of what our graph looks like? It's okay. The scale on the x-axis is very different than the scale on the y-axis, but for the purposes of sketching, it's fine. So the vertex is always smack in the middle. And if you can plot the side with the y-intercept, then the other side of the parabola will be a mirror reflection. Okay, let's do one more. It's my experience that the more things I leave out, the more confused people get. So if I did y equals negative 2x squared plus 1. What's missing is the parentheses here, just kind of like the k was missing, but it's still in that correct form. So maybe if I wrote it like this, negative 2x minus 0 squared plus 1. I often get the question, Mary Beth, how did you know to put a minus 0 instead of a plus 0? It's 0. It doesn't matter whether you put minus or plus. The formula prefers the minus, so I may as well do that. And this can tell me that the vertex, I'll just call it V, is at 0, 1. So x is 0 and y is 1. And for my one more point, which again, I'm going to plot x equals 0, is going to be, let's see, y equals negative 2 times 0 squared plus 1 is 1. So 0, 1. Oh no, that is my only point. Well, that doesn't help me graph one. So in this case, because I only have one point, I do need to do an extra point because I just got the same point again. So I'm actually going to erase this. So if you're unlucky enough that your one more point, which is your y-intercept, is the vertex, then pick something else. Maybe pick x equals 1. So y equals negative 2 times 1 squared plus 1. So we get y equals negative 1. So x is 1 and y is negative 1. X is 1 and y is negative 1. Now remember, the first point we plotted in green here is the vertex, and that is always in the middle. So when I go to graph my parabola, I go from the vertex to the one more point, and then a mirror reflection on the other side. Okay, let's do the same thing, but when these parabola equations are written in a different form and not in vertex form. So what about a parabola that's written in this format? Y equals x squared minus 8x plus 10. So it has the y equals x squared, so I know it's going to be that parabolic shape, but it's not written in our vertex form. The 8 and the 10, unfortunately, are not our vertex. Here's what we're going to do. We're going to use completing the square in order to get this into our nice vertex form. Okay, now here's how to do that. Pay close attention because it's a little bit different than the completing the square you did a few weeks ago. Y equals x squared minus 8x. I'm going to leave a little bit of space and then plus 10. And remember, what we're looking for is x minus h in parentheses squared and then a plus k on the outside. So the number next to the x, if you remember completing the square, you take that number and you cut it in half and then square that result. So negative 8 divided by 2 is negative 4, and negative 4 squared is 16. Now here's what I'm going to do with the 16. I'm going to add it. Oh, I need to move. No, I don't. I'm going to add it at the end because that's the number that will make, or I'm sorry, add it at the end of the x squared and the 8x. That's the number that will make this factorable, x squared minus 8x plus 16. But I can't just go adding 16s wherever I feel like it. So I need to make up for that by subtracting 16 also. The plus 16 will help factor things. So x squared minus 8x plus 16 is x minus 4 squared. And the minus 16 will combine with the other number, the other constant, to be our k. 10 minus 16 is negative 6. Okay, so just to recap before I get all excited and start graphing this, you take the number next to the x, divide it by 2, so cut it in half and then square it to get your 16. The 16 is added right after the x term and then subtracted on the outside. The first 3 terms will factor now, and the 10 minus 16 will become your k. So now we have the vertex is 4, negative 6. So 1, 2, 3, 4, negative 6. Thankfully, it's not a y-intercept, so if I'm doing my math lab or anything, my one more point, the y-intercept would be great. So this would be, oh, you know what would be nice? Let's plug it in here, x equals 0. That'd be so quick. 0 squared minus 8 times 0 plus 10. Y is 10. 0, 10. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now remember, start at your vertex and go to your y-intercept or your other point, and then do as best you can a mirror reflection on the other side. Mine's a little bumpy. Okay, let's practice this one more time. I lied. Let's practice this 2 more times. So for the first one on this page, let's graph y equals x squared plus 6x minus 2. Okay, so here we go. I'm going to move some things around. So, I'm going to scoot you down here. Probably going to need to do this too. Okay, that's better. Okay, now I can work. Y equals x squared plus 6x. Give some room, and then minus 2. And we complete the square using the 6. So 6 over 2 is 3. 3 squared is 9. So I'm going to add 9 and then subtract 9. So that really what I'm adding is a big fat 0 in red. All right, so this will give me y equals, let's see, x squared plus 6x plus 9 is x plus 3 quantity squared. And negative 2 minus 9 is minus 11. So I can tell pretty quickly the vertex is negative 3, negative 11. Let's see, negative 3, negative 11. Ugh. There's our vertex. And our one more point, when x equals 0, I'm going to look up here. So easy. Plug in x equals 0 up here to get the y-intercept. 0 squared plus 60 minus 2 is negative 2. So 0, negative 2. So there is a good thing about having to complete the square. Your y-intercept is pretty easy. And then start at the vertex, go to the one more point as best you can, make a mirror reflection on the other side, and you have a parabola. Okay, last example in this type, and this is an important one to pay attention to. Y equals negative 2x squared plus 8x minus 3. Now, if you remember from your completing the squares section, the negative 2 in front of the x squared, which is new, we haven't had that yet, it totally messes up all of your completing the square. So here's what we're going to do. We're going to factor out the negative 2, but I'm not going to factor it out of the plus k stuff. So I'm just going to factor out the negative 2 from the first two terms. So that will give me, let's see, negative 2 divides into negative 2x squared, gives me x squared. Negative 2 divided into positive 8x gives me negative 4x. Leave some space and then put your minus 3. So I'm going to say that one more time. Don't factor out a greatest common factor. That would include an x. Just factor out whatever coefficient number you have in front of the x squared. In this case, that's a negative 2. And be very careful with your signs. So negative 2 into negative 2x squared is x squared. Negative 2 into positive 8x is a negative 4x. You can always double check, by the way, by distributing the negative 2 through. Negative 2x squared and positive 8x. And leave that constant, that negative 3 on the outside. Now when we complete the square, we're going to complete the square using the negative 4. Negative 4 divided by 2 is negative 2. Negative 2 squared is 4. So that's the number that I'd like to add and then subtract. But wait, there's more. Okay, pay close attention to what I am about to say. The number we added inside the parentheses, the plus 4, was needed to make x squared minus 4x plus 4 factor. However, the number we added inside the parentheses is inside the parentheses. If it's in the parentheses, it's being multiplied by the negative 2 on the outside. So whatever I subtract off must also be multiplied by the same negative 2. If you were, by the way, there's no reason to do this in the problem, but if you were just to check your work really quickly, negative 2x squared plus 8x minus 8, if I were to distribute that negative 2 through, minus 3 plus 8, because negative 4 times negative 2 is positive 8. And what I want to draw your attention to is the negative 8 here that came from distributing the negative 2 through, and the negative 8, or the positive 8 on the outside that came from multiplying negative 4 by negative 2. So what you want to do is, if you had a constant coefficient that you had to factor out of the first two terms, cool. Just make sure when you add and then subtract whatever number you get from completing the square, you multiply that by that constant coefficient. Even though I won't be formally graphing these, we'll be practicing that quite a bit in the last remaining examples. Okay, let's finish this one. So let's see, the whole point of all of that was to make this factorable. So x squared minus 4x plus 4 factors to x squared minus x minus 2 all squared. And we have minus 3 plus 8. So negative 2 times x minus 2 squared plus 5. So my vertex is at 2, 5. There we go. 2, 5 is the vertex. And the one more point, again, I'm going to use this thing. When x equals 0, y is -3. So I have 0, -3. 1, 2, 3. So go from the vertex to the one more point. And mirror reflection, and there's my parabola. The next type of problem you're going to find in your homework are problems where we kind of go the other direction. Instead of giving you the equation and then asking you to graph the parabola, we go the other way. We give you the graph and ask you to find the equation of the parabola. So I wanted to steal one. This is actually out of my own version of the My Math Lab homework. And let's say we're looking at this parabola here. I can tell from the graph that the vertex is at -4, 5. And the one more point, they chose the same one that we did. We also have x is 0 and y is -11. And they were even nice enough to label it for us. So if we're going the other direction and finding the equation of the parabola, we're going to use the standard form that had the vertex form in it. So a times x minus h squared plus k. And we know our vertex is h and k. So in this one, since the vertex is -4, 5, h must be -4, and k must be 5. So this would give us, I don't know a yet, a times x minus -4 squared plus 5 would be a, and x plus 4 squared plus 5. Very cool. Now we're going to use our one more point, x and y, to figure out what the a was. And you do this pretty simply. All you're going to do is you're going to plug in that one more point for x and for y. So that will look like this. Y equals a x plus 4 squared plus 5 will now be, let's see, the y is -11. Whoops. -11 equals a, x was 0, plus 4 squared plus 5. And then solve for a. Okay, cool, here we go. Let's see, 0 plus 4 is 4. So I have -11 equals a times 4 squared plus 5. 4 squared is 16. -11 equals, I need to move up, I'm gonna need more room. -11 equals a times 16 plus 5. Subtract that 5 from both sides, and we have -16 equals, I'm going to write this as 16a. That's killing me, a16. Divide both sides by 16, and we have a as -1. So now I know the standard form of this parabola is -1, which I'm not going to write the 1 in, just the negative. Negative, parentheses, x plus 4 squared plus 5. Okay, couple of things to note here. The a being negative, notice that always comes from the reflection, so it's going to be a parabola that opens down. So I feel like that's really comforting to know that we're probably on the right track. If the a had been positive, that would have been a parabola that opens up, and we would have had some problems because this parabola does open down. Any parabola that opens down is going to have a maximum value at the vertex, and any parabola that opens up is going to have a minimum value. So let's practice a word problem that deals with that concept. Let's finish with a word problem straight out of your homework. So suppose that the manufacturer of a clothes dryer has found that when the unit price is P dollars, then the revenue R is given by the formula R of P equals negative 4P squared plus 12,000 P. What unit price will maximize revenue, and what is the maximum revenue? So, for starters, you folks in the class that are business majors, this is a fairly well-written word problem, pretty accurate, actually. The higher you make the price, true, you're going to make profit or revenue, I guess, off of all of those that you sell, but you're going to lose customers. People, if you made a $30,000 clothes dryer, you're probably not going to sell very many of them. If your clothes dryer was $30, you probably sell a ton of them. But then you have to think overhead and all this. So this function right here is the revenue. So not the net, but the revenue. Okay, generally in a word problem in a parabola section, whatever they're asking you for is probably given in the vertex. And in this case, notice that since this parabola has a negative a, so negative 4 in front of the p squared, that means R of p is negative 4p squared plus 12,000 p. So that means I know from the graph that it's going to open down, which means that our vertex gives us a maximum value. On the other hand, if it was a positive 4p squared plus 12,000p, then it would open up and in that case, the vertex would be at the bottom, so the vertex would give us a minimum. And there are some homework problems that just ask, without graphing, will this parabola give you a minimum value or a maximum value? And what you look at is the coefficient in front of the squared term. If it's negative, then the parabola will open down. So I know automatically this will give us a maximum revenue. If it happened to have been positive, it would have opened up. So the vertex would give us a minimum value. So really what they're asking us for in this problem is, what's the vertex? What's the unit price? What's the P? And then what is that maximum revenue? So here's what we're going to do. We're going to do the completing the square thing that we were doing a few minutes ago. So R of P equals, okay, there is no extra constant term, so I'm just factoring out the coefficient, the negative 4, from the first two terms. P squared, and then be careful with your signs. Negative 4 goes into positive 12,000 P, leaving us with negative 3,000 P. Leave some space, and then put a parentheses. Okay, complete the square. So let's see. I'll go to my red pen. Negative 3,000 divided by 2 is negative 1,500. Negative 1,500 squared is 2,250,000. So that is the number that I'm going to need to add here with very small handwriting, 2,250,000, and then subtract 2,250,000. But don't forget, there's a negative 4 out front multiplied by negative 4. Okay, so that gives us R of P is negative 4 times, okay, a little shortcut for factoring these. If you remember from your completing the square section, it always factored to what this number is in the step after you divide by 2, but before you square. So it's going to factor to P minus 1500 squared plus 9 million. Okay, so I can tell right now that the vertex is 1500 and 9 million. And I'm going to scooch this up just a little bit, but not too much, because I still want to look at be able to see the question. What unit price will maximize revenue? This part, let's get a yellow highlighter. I'll put down here. This part is asking for the p-value, because that was the unit price. I'll also highlight it where it told me that. The unit price is $P. So I can tell that the unit price that gives me the maximum revenue is $1,500. So charge $1,500 per clothes dryer. And the part of the question that asks me what is the maximum revenue? So what's the maximum R? That is the 9 million. So here, the maximum revenue is the maximum of the function. And that would be $9 million. So you should charge for your company $1,500 per clothes dryer. And if you do that, you should expect to make a maximum of $9 million.